top of it. Okay, so type 3, you're basically trying to find a third point. So within the word problem, you will be given two. Sometimes actually it only seems like you're given one, but I'll tell you why that is. And it often talks about projectiles or something that follows a path. So if you're in physics, you will do this a lot, or you are doing this already, right? Projectile motion. So with this type, you will have to determine the missing point or the third point in order to perform a regression, because you need a minimum of 3, right? It is best to create a sketch, right? You label the point. So that sketch is not necessarily, doesn't have to be fancy or have all the components unless I'm asking you to graph, okay? Then use the symmetry of the parabola to find a third point, okay? So that's very important, using the symmetry. Sketch, label, use symmetry to find the third point, okay? So the first example we have here is you throw an apple core up in the air while standing on your balcony, right? The balcony is 6 meters above the ground. You estimate that the core reaches a maximum height of 13.5 meters after 2.5 seconds. So determine the quadratic equation. You need the equation to be able to answer this domain and range, or else you won't know. Okay, so here you almost have to just read and interpret. So to solve I'm just going to make a sketch. Okay, this is not an actual graph, but I do know based on the context that there's time and there's a height, right? Now, are you starting right on the ground? No, right? You're standing up high on a balcony somewhere up here, right? This is 0.6, that's your initial height. And it's mentioned, obviously there's a lot of things not mentioned, but we're assuming you're throwing it up in the air, so the apple core will follow this path, right? It will follow a parabolic path, right? And you will see this in physics, right? If you take it, you're going to have quadratics in there. You might just not call them quadratics, right? So this is your initial height. Is there anything else we know? It's telling me that it's giving me the maximum height, right? It's the maximum height. So maximum, in a sense, what should you be thinking of? The vertex, exactly. So this is essentially the vertex, right? And you have to be careful in the correct order, right? 2.5, 13.5, right? Like that's what they're giving you there. So we're going to go ahead in our diagram and find the vertex and label it accordingly, 2.5, 13.5, like that. Okay, so you have 2 point, great. Can you perform a regression? No, you need a third one, okay? That's where I'm going to ask you to use the symmetry. So what I do is I start with the initial height and I draw a dashed line out like this until I hit it again on the other side. So remember the cousin, right? Right, there's one here. You're gonna go up and then come back to that height at one point. So I know that the y value is 6, right? I just need to come up with this, the x value. And I'm going to use a different color and say, well, let's use the symmetry. Remember the axis of symmetry? It goes through the vertex. So you go like this, through the vertex, like that. How long did it take to go from here to the middle? How many seconds went by? This is time. 2.5 seconds, right, to go from here to here. When you're looking at time, you're going from 0 to 2.5. So this is 2.5, right? So how long is a rhetorical question, right? How long would it take to get back to the same height. 2.5, right? That's symmetry, right? It's the same distance to either side. So this is essentially going to be 5. Okay? And I'm going to do this for your notes, right? It's essentially times 2 in this case, right? You double the time that it took you to get to the highest point, because you know that it's going to be another 2.5 to get back to the starting point. You could have used axis of symmetry though, right? Remember that formula? You can use that one. I don't know if I want to get into it right now, but you could be using that. Remember, x is equal to x1 plus x2 divided by 2? You could use that here, right? This is your x, this is x1, which is 0, and this is x2, so you could find what that is. Common mistake, for whatever reason, I kind of understand it, but most students will remember the times 2, but will put the point down here. They'll say this is 5, 6 or 5, 0, right? No. It's in line with where you started. Okay, so you'll see some other examples there. This is the third point, right? This is the third point. So that is important. That's going to be worth 1 mark, right? So this was given, third point, you determined that. So this one is, I think you will like this one more because, right, if you have x and y here, you just fill in the numbers. So 0, 6, 2.5, 13.5, and 5, 6. We plug this into L1. So this type doesn't have the 3 columns, right? This goes into L2. So it's, right? So we're going to do a stat, calc, quadratic, and we're going to come up with our equation. I'm going to ask you to do that. Stat calc 5, comma 1. And there it is. I'll just show you that. It's negative 1.2x squared. Don't forget that. Plus 6x. This one at the end here, I'm pretty sure you would have expected that. Keystrokes, and you give me the equation. This would definitely not be 1 mark, right? This would be one mark for coming up with the 3 points somehow and coming up with the equation. Okay, so you gotta watch out for that. B. State the domain and range. For the domain, now that you understand it a little better, I know that it's time, right? So it's from 0 to X-intercept. I need to find that. Range is going to be, is 0 going to be part of my range? Yes, because you do hit the ground, right? The apple core does. It doesn't tell you that it's not, right? So we're assuming that it's going to be 0 to vertex, right? Y value of the vertex. if that makes any sense. The y value of the vertex. Do we know this part? Yes, we do know. So for the range, it's just 0 and it's 13.5. Done. Like we already knew that. They gave us the vertex. X-intercept, we're going to go ahead and find it. Okay, you have to find it. You don't know what it is. It's not 5. So let's graph it, okay? Same as before. You're using L1 and L2. Therefore, plot 1 should be turned on. I can't see a thing right now on my calculator. I just went ahead and tried to graph it. But plot 1 should be turned on, then you go zoom 9 right away. And there it is. But remember, the same applies. I go window, I just change that to -5. If you want to go -2, sometimes -5 shows too much. So there it is. And again, you want to omit the negatives, right? So you're just basically here in the first quadrant. Let's go ahead and find the x-intercept. You want to go over the hill, closest to that, enter, enter, enter. So that's 5.85, 0, right? So the domain is 0 to 5.85. Yeah? Yes, I would. If you haven't found this anywhere up there, then show the work if it's the first time you're finding it, okay? But if I had asked you earlier, when does the apple core hit the ground, like in a question above it, if you just grab it there, because then you will have shown the steps over there already. Yeah. Okay, so for A, this is not the x-intercept. This is just a third point. Okay, we know that it takes 5 seconds for the apple core to be back to a height of 6. Got it? You need 3 points before the calculator can come and make a model that would fit those 3 points. Yeah. All right. Okay. So I have a couple more. I shortened them a little bit so that they're not too wordy, but then at the same time, I want them to be wordy so that you're not panicking when that does happen. So here we are. Very simple, right? A ball is kicked up and it lands 65 yards away from the kicker or the person that kicked the ball. Determine the quadratic equation. Now, I'm assuming that you will agree with me that there's a height involved here, even though it's never mentioned, right? So we will call this distance and we will call this height, right? So the height is there, even though it's not explicitly mentioned, right? It's implicit. Okay, so sorry, this is A. This is our journey to solve A. Okay. So it's important to know, where do you start? Are you starting off the ground or on the ground? So in this, it's it's on the ground, right? You're kicking the ball, unless you're a goalie, right? But other than that, it's not saying that, it's not telling us that it's being held above ground or anything like that. So our assumption is we start here. So it's 0, 0. That's when I mean that a lot of students think they only give you 1 point. It's like, what do you mean? Like, I can't do anything. 0, 0. Don't underestimate the power of the origin, right? 0, 0. So the ball then makes a trajectory that goes like this. Okay, where does it land? It lands right here. And the distance is first, so 65 yards. And what's the height at this point? It is 0, right? So it's actually easier than what you think, this one, because, right, you start at 0 and you come back to that height at 65 yards from there, okay? So, oh, I forgot to tell you something, right? You're probably already wondering. I will just tell you this. The ball, I didn't write that down. I will get it on my notes here. It reaches, ball reaches a maximum, height of 50 feet. My bad. You can't do it if I give them. The ball reaches a maximum height of 50 feet. Make sure you add that, okay? Or else you won't know what happened here. Okay? So we know this. That's where it got, right? You kicked it from here. It landed 65 yards from you, and you know it's 0 again. We know that our vertex is going to be located at the highest point, so somewhere over here. This is not drawn to scale. It's just a sketch. So that one I want in red because, right, we know that the maximum height here is 50 feet. We just have to come up with the x value here. And again, use symmetry. Okay. So basically, you know that from here to here is the same thing as from here to here, right? So if you were to go back from the where it landed to the center, that would have to be half the time, right? Because it's half the time here and half of the time the ball is over here. So in this case, you would not multiply by 2, but instead do what? We would divide by 2, okay? You divide that one by 2, okay? So you get 32.5. So what you basically just found here is that it takes 32.5. This is not really necessary, 32.5, and it will take another 32.5 here, right? It's 65 in total. So dividing it by 2 gets you half of the time, which is where the vertex would be located. Okay. So now we can come up with the equation. So we're going to come up with our x and our y. Okay. So it's 0, 0, 32.5, 50, 65, 0. Put this into L1, we'll put this into L2. We're going to go stat, calc, quadratic. How are your batteries, folks? Halfway? Okay. So I'm just going to bring this up here. That's what I have. I'm going to go to the home screen because I just performed a regression. And you get negative 0.05 x squared plus 3.08 x plus 0, right? Which is not necessary. And now I could ask you anything, right? What's the distance this ball stays at or above 30 feet, let's say, right? I could ask you anything I wanted, just like before. So it's just that added step, right? All of these regression questions first start off with come up with the equation. And now that you have an equation that models the situation, we can ask everything, right? Anything in between. So let's come up with our domain and range. This one is particularly easy. It's 0 to 65 for the domain, and it's 0 to 50 for my range. That's it. If you want to use a different letter other than Y and X, I would suggest you write it down somewhere here. So for example, if you wanted to use D for X, right, and H for height, that's fine. Just write it down here and then use those letters in your equation if you'd like. But this would be very, very good enough labeling and everything. Okay. So now I'm going to give you a third example that I want you to try. Okay. So let's see if you could, at this point, after 2 examples, figure out how to do this. There it is. So write it down, and then I'll give you, should take you, under 7 to do this. Your final answers, yes. Caught myself again. And 0, right? So this is these are your 3 points. L2, stat, calc, quadratic. Y is equal to, according to mine, is 0.06x squared plus 0.43x. That's what you're supposed to get there. And now it's asking me determine the distance spent at or above 0.55, right? So I'm going to make y2 equal 0.55. I'm going to go ahead and find those two instances, right? So I will just make a little sketch here again. Right? So this is the 0.55 line. So there's two x values that I'm interested in, because when I subtract those, I'm going to get the distance spent at or above this height. Okay, so the first one is 1.711684. That's the first one here, and the second one is 5.088316. So second trace 5 here, second trace 5 there. Intersect, intersect, right? So these two are at a height of 55. So delta distance, right, not time in this case, is these two numbers subtracted. And that's when you round to 2, which is 3.38 meters at or above 55 meters, 0.50. And C is the good old domain and range, which should be fairly simple here. But again, always read carefully. Does this thing land somewhere or not, right? Like if you start off the ground and you land on a surface that is off the ground, you're never touching the ground, so 0 should not be part of it. And it is coming, okay? You just have to be prepared for that. Okay. I'm going to give you another one. And then I will already get you started on the type 3 worksheet. If we get, I think we might have 15 minutes left. So we can just do the worksheet. But this one will be a little longer. Example 4. And I posted a survey. Maybe that's what I'm going to ask you to do before surveys. They really help me. Okay, even though you think like, I don't know about me, but if I get a survey in the email, in my email inbox, or somebody calls me, I just hang up, right? But this one, I would really appreciate if you didn't. Okay. Reaches a maximum height. So just write this down, okay? I'm a little behind with my notes here. That stands for equation, by the way, EQN. See if you can figure this out. For this to be on video, right, before we conclude, right, I have this already worked out, so it might not be as pretty as you would like it to be, but anyway, so you schedule the 3 points, right? So the diver starts, right, 2 meters above the ground, reaches a maximum height of 3.1. We don't know this yet, but that means that we're coming back to, right, the splash is happening here, but you always draw a horizontal line out because you're coming back to that, right? Since 1.9 is when you reach that maximum height, you double it, so it'll take 3.8 seconds to get back to 2 meters. That's very important. Don't put it down here because then it'll throw everything off. And then, so this would be the sketch. That's good enough. No, it doesn't have to be, it's not a graph, it's just a sketch, okay? So then it's time and height, or X and Y. You plug in your values. You come up with your equation, which looks like this. If you round it to 2 decimals, that's fine, right? But notice that here it's plus 2. And C is asking how long until he reaches the water. So it's basically finding the X-intercept, right? It's here where it happens. So you're going to find that point. So that's, okay, that should be the first alarm, right? That should be the first bell. It's like, wait a minute, didn't I just find that, right? Like a lot of, don't feel bad if it happened to you, right? But I can see a lot of students saying this is 3.80, right? Yeah. Here? Yeah, that's fine. Yeah, absolutely. And I don't see a lot of you forgetting the y equals, so way to go, okay? Because that's automatic minus half, right? So out of that 1 mark you get for the equation, half is gone, right? So you don't want to do that. Yeah, rounding to 2 is good. More than 2 is good as long as you do it correctly, okay? If I find that this should have been a, a 4 or something, and you put a 5 down, then you still lose the half mark. So whatever you choose, a minimum of 2 though. So anyways, the X-intercept is 5.09. That's right here. And that's how long it takes until he reaches the water, okay? Then it's asking us for the height of the jumper after 2. Why do I have 2.5 here? I gave you 2.4, right? Oh. Okay, what is it if it's 2.4? 3.02? Yeah, I see a bunch of nods. So sorry, I don't know. Somewhere I dropped the ball on that one. So E, it says time at or above. Did I get that right? Yeah, that one I got right. 2.75. So you find the 2 points. If you don't want to graph, this is how you would show it, right? The first point, the second point. I use at least 4 decimals, preferably all decimals, but 4, if you use 4, you're not going to have the rounding early mistake. And then delta time would be subtracting these 2 instances on its way up, on its way down. It happened between that time, so it's 2.14. So the domain is this to this, and the range is obviously to the max there. And that is it. So homework. Type 3 worksheet, which you should have. If you don't have it, I have a few extras here. If you happen to be here and you don't have it, it looks like this. It's like a little booklet, right? Work on that. I will just, right after this, I have it already ready to go. I just have to click it and then it's posted, okay? So if you don't have this, I will have the PDF and the key there at the same time, okay? All right, have a good one, everybody online. You can log off. Thank you. Have a good day. See you tomorrow, some of you. If you're here, just wait for the bell, and I wish you a good week.